In the 21st century, planet Earth has been heating up significantly year after year. When it comes to the hottest temperature ever recorded, 2019 broke records across the globe, while 2020 shattered them. What was once a naturally occurring seasonal event is now being attributed to the increase of carbon emissions that is wearing away at the Earth's fragile atmosphere.
If we fail to act on this problem, it starts to look like some of the dystopian futures that have been portrayed by Hollywood. Post-apocalyptic, where a large part of the planet becomes unlivably hot and dry, and where you have extreme competition and conflict over diminishing food and water and space. There is a path forward where we do preserve this planet for future generations, for future human civilization. It's a matter of whether we have the willpower to tackle this problem before it does become too late.
Unless the current trends are reversed, humanity is on a collision course to make more regions of the world uninhabitable, where boiling temperatures could be the new normal. It's all due to one of the deadliest weather events ever known, the heat wave. Hot weather that can last for several days is generally known as a heat wave.
Well, a heat wave is an extended period of extreme heat, several days, typically with temperatures above a threshold like 90 degrees Fahrenheit.
Heat waves can have a significant impact on the environment, society, and human health.
Heat waves really are a silent killer, especially with the young and the elderly and the infirm, who have the least resilience when it comes to coping with high temperatures.
Now, a new report suggests that by the end of the century, heat deaths globally could nearly equal those from all infectious diseases combined.
It's called a silent killer for the reason that heat wave do not descend upon an area with a bang. They creep in slowly, impact populations over an extended period of time, and also there are no visible signs of destructions associated with heat waves, as is the case with some other natural disasters.
They are triggered by high-pressure systems that hover over an area, absorbing heat beneath it like an oven. High-pressure systems push the air down. Hot air near the ground cannot escape into the sky. Without the rising air, no clouds form, and consequently no chance of rain. The sun simply cooks a given area until some other system is strong enough to push this stagnant high-pressure system away. The longer the heat wave lingers, the deadlier it becomes for all life under its spell. This was the case in 2003, when one of the worst heat waves on record struck France and much of Europe. In a cemetery outside Paris are the graves of 57 people who some consider to be the first casualties of global climate change. Here lie the victims of the worst natural disaster in French history.
One of the first signs that we saw that climate change was really dramatically increasing the incidence of these extreme heat events, extreme heat waves, was the summer heat wave in Europe in summer 2003.
But this devastating heat wave that begins in August does not come without a warning.
In June, we had early signs that were linked to soil drought in Western Europe. Since we had a particularly dry spring, so the soil was already very dry. If there is little humidity in the soil, there is no evapotranspiration phenomenon, which would allow France to cool down.
To understand how it works, of course, it's like in summer we throw water on the terrace to make it cool. It's the opposite. If the soil is dry, it can't evaporate water and therefore cool the lower layers of the atmosphere by the latent heat. Thus the fact that it cools when it evaporates. If this phenomenon is diminished, obviously the heat wave is amplified. If there will be weather conditions for a heat wave, it will be severe. When I started to have concerns, at the time I was living in a very big suburb, and on my way home by motorbike I would pass through some woods, and in fact I had noticed things. Leaves were falling. Leaves were falling, I thought. That's strange. And there were tree branches cracking and falling. I said to myself, how odd.
In the early summer of 2003, plants and leaves wilt away, succumbing to a drought. There is no moisture left to evaporate, a bad omen of what is yet to come.
In 2003, we had one of the first events that made the link between drought and high temperatures so obvious. These things are very well known now, but in 2003, we didn't necessarily fully anticipate the fact that this drought in the soil was going to intensify the temperatures as much as it did.
It begins with a warm air mass that moves northeast from the Mediterranean across Spain and into France.
You had the sort of heat that you would normally expect in North Africa, in Saudi Arabia, parked over England and France. This high-pressure region that's normally centered in the subtropics had migrated all the way up into northern Europe.
The heat wave is parked over Western and Central Europe. The air mass is part of a phenomenon known as an anticyclone, a large-scale weather system bound by slow-rotating winds and marked by extremely high pressure that prevents other systems from displacing or disrupting it. Since the air mass doesn't move much, the temperature begins to rise.
The anticyclonic conditions, the blockage that had settled over the European continent, was self-sustaining by the hot air that fed it, and nothing could come to change it. On the 1st of August, Météo France issued its first meteorological press release signaling the arrival of very high temperatures over France over the coming days.
Well, the temperatures in Paris on Monday have been absolutely sweltering. We've had temperatures forecast up to 35 degrees Celsius, which will feel more like 41.
Despite the warning, the heat appears primarily as an annoyance to the general public. August 1st kicks off the traditional summer vacation ritual in France. People are leaving the cities and heading toward beaches, the countryside, and mountain resorts.
It's hot, it's summer, it's holidays. We do what we want. Heat is nothing. It's a sign of happiness, etc. All wrong, all wrong, all wrong. The message didn't get through from this famous first week.
Media coverage focuses on the heat as a human interest story, the devastating consequences for the nation's farmers. Emaciated livestock, parched fields and blazing forests is what the country is watching on TV. Stifling temperatures in Paris create a boom for cafe owners and bottled water vendors. But not everyone is oblivious to the danger.
At the time, I was president of the Association of Emergency Physicians of France, and we had consultations with the ministry, and we had an appointment with the Minister of Health, Mattei, at the time. And I told him, we really have a problem with hospitalizing people from the emergency rooms. We were already saturated. And I told him, it's going to be very complicated in the summer. Why? Because the staff were taking their summer holidays. Hospitals weren't hiring staff, so we were closing beds. And we didn't hire staff. The consequence was that people were having to wait in the emergency rooms.
But how does humanity prepare for such a potentially catastrophic event? It starts with time. Scientists at the National Center for Atmospheric Research in Boulder, Colorado, are using computer simulations to develop a short-term forecast model for extreme summertime heat. They're looking back in time to see how accurately their model captured heat waves globally and in the various seasons.
we are getting better in our weather forecasts, in our ability to forecast, for example, periods of extreme persistent heat, a week out or even more. And that provides us lead time where we can notify people in advance to take the precautions necessary to deal with upcoming extreme weather events.
Today, heat waves can generally be predicted 2 weeks ahead. But the goal of the National Weather Service in the United States is to achieve a 3 to 4 week advance forecast. With time to prepare, endangered populations around the world will be able to react quickly. In India, detecting a heat wave in advance will reduce its impact and save lives.
People seek shelter wherever they can. The combination of searing temperatures and hot winds has turned much of India into a furnace.
As far as the tropical areas are concerned, where India is located, the high-resolution general circulation models are now capable of providing us quantitative and location-specific forecast of temperature, along with actionable recommendations for about a week in advance. These accurate predictions, when communicated to the communities which are going to be impacted, along with the health system preparedness, which involves not just the meteorological department, but there are many other agents involved. It helps us put in system in place that has helped the country to bring down the casualties.
Advanced warnings mean extra time to prepare your home to stay cool, to ready public cooling centers, for utilities to prepare the electric grid for the surge in power consumption from air conditioning, and to stock up on water and food supplies to avoid traveling outside. Just how does the human body cope with extreme heat? Our bodies strive to maintain a constant internal state of 98.6 degrees Fahrenheit or 37 degrees Celsius. But when the outside air is consistently higher, the body reflexively cools down.
Human body normally cools through respiration, that is cooling of sweat from the body. The sweat evaporates and which leads to cooling. But a prolonged exposure to heat can overwhelm a body. An overheated body suffers involuntary muscle spasms, muscle failures, and also widespread inflammation in the body. The dilated small blood vessels are an indication that the blood is not being returned to the heart properly. The reddening of the face and the body, they give us a signal that the muscles are not able to pump the blood back to the heart.
The first sign of hypothermia is irritation. I mean, someone who doesn't drink enough. It's people who get annoyed while driving. It's worse for people who are already sick and take drugs, which can disturb thermoregulation such as neuroleptics, particularly psychiatric patients. And of course, the elderly. We can be very hot during the day, very hot. It doesn't matter, as long as it's cool at night, your body will recover. Where it gets problematic is if it's very hot and the temperature doesn't drop at night, so your body doesn't recover.
If nighttime temperatures are too high, then you see high rates of mortality with these heat waves among, again, the elderly and the young. And it is, in essence, a silent killer. Many of these people, unfortunately, die in their sleep because of the heat stress from unprecedented levels of warmth.
In Paris, troubling signs of a disaster in slow motion accumulate. Temperatures remain abnormally high, with no let-up at night. Nearly all domestic news coverage is connected to the heat. Reports of uncontrollable wildfires, stories about excessive ozone pollution, and farmers complaining of drastic losses of livestock fill the airwaves. Stories about the homeless in Paris appear on television. City shelters are closed because of short staffing. If cooling centers are not available, the severe heat stress on children and the elderly will result in a catastrophe of human mortality in the French capital.
We got the information from our colleagues in the ambulance service that there had been about 10 cardiac arrests during the night. That's when I said to myself, something really strange is happening. The emergency wards were overflowing everywhere in Paris, in the center, etc. We warned the authorities, but there was no response. Everyone was on holiday. In fact, there was no communication plan, no communication officer, nothing at all. I said to a team from TF1, "It's a disaster. We can't cope anymore." I said, "Nobody cares at all."
On August the 4th, 4 days into the 2003 heatwave, much of Europe is smoldering under the intense sun. Nowhere is it felt more acutely than in Paris, France.
We already had problems finding beds to hospitalize patients in the emergency room. The emergency room was already saturated. We were closing beds. We were saving money. We weren't hiring staff. And people were waiting in the emergency room. It was a real cataclysm. And it's a very heavy burden to carry when you're a doctor all alone.
A health worker in northwestern France reports 3 deaths due to heat stroke. 2 died with body temperatures exceeding 107 degrees Fahrenheit.
The afternoon of the 5th of August 2003 remains the hottest we have in our archives, close to 38 degrees. This record has not been broken. We were really shocked. It was completely different to what we had seen before.
As global warming increases, so does the occurrence of heat waves across the globe. Places like India and the US are seeing more of their share of this deadly weather event.
We now have systematic records of heat-related casualties for about 30 years now. And during that period, the year 1998 experienced the deadliest of the heat waves, when 3,058 people died directly because of the heat wave impacts.
In the 2015 heat wave in New Delhi, temperatures are hot enough to melt pavement in the capital city.
The year 2015 comes second behind 1998, when the heat-related deaths across the country stood at 2014. After that, we have put a system in place involving the meteorological department, the health agencies, and other stakeholders, which has helped bring down the heat-related casualties across the country.
In May 2019, a deadly heat wave sends temperatures above 120 degrees Fahrenheit in northern India. But now, Indian authorities are armed with preventive measures, like warnings to the public not to go outside after 11 a.m., or pouring water on roads to keep them from melting. The death toll for that summer's heat wave is limited to 373.
Highest temperature ever on Earth, with mercury levels rising to 54.4 degrees Celsius on Sunday afternoon.
We witnessed the hottest temperature ever recorded on this planet, ever recorded reliably on this planet, 130 degrees Fahrenheit in Death Valley, California.
In this case, we recommend that you obviously make sure that you're staying away from the sun and limit your outdoor activity to the late evening, right when things tend to cool down.
And that was at a time when, in fact, all of California was seeing extreme heat with temperatures at 120 degrees Fahrenheit in Los Angeles.
A recent US government report confirmed that the years from 2010 to 2019 were the hottest decade since record-keeping began 140 years ago. And 2020 is the warmest year on record globally. Unless nations of the world take dramatic action soon, a warming of at least 5.4 degrees Fahrenheit, 3 degrees Celsius, is expected by the end of the century, making the Earth roughly as warm as it was in prehistoric times, 3 million years ago, long before Homo sapiens appeared. Human beings have never lived on a planet as hot as the Earth is today. A 5.4 degrees Fahrenheit warmer world would be radically different from the one we know now. Rising seas could swamp cities. Epic droughts will turn rainforests into deserts. The increased heat alone would kill significant numbers of people. The result is clear. The warmer the world becomes, the more people will die. Back in France, the French television network TF1 reports on a catastrophe in the making. High temperatures melt electric lines and swell train tracks, stranding thousands of passengers in overheated train cars during one of the country's busiest travel periods.
People were dying. We didn't have enough equipment. Things were not going well at all in hospitals. When you're surrounded by dead bodies, it's really very demoralizing. And we had to comfort the nurses who often cried. Our morale was very low, but we kept going in order to save as many lives as possible. We realized that we are facing an event that has never been seen before. The weather models already predicted that we were going to beat the absolute temperature records, and the feeling was one of incredulity, the impression of experiencing something quite incredible.
While French health authorities raise concern that the country might experience hundreds of excess deaths linked to the heat, French media fails to take any interest. At the time, national health authorities have no idea that 6,500 people had already died from the heat's effects. Many are elderly, found in their apartments, nursing homes, or homeless on the street.
The temperatures remained at the same level from the 2nd of August. If there was a change in the air mass, it didn't affect the temperatures. There was a press release that was issued on 8th of August to emphasize the exceptional temperature level and the worrying consequences for human health. On the 8th of August 2003, the meteorologists from Météo France clearly identified that these extreme temperatures posed a health problem.
Even hospitals struggled to stay cool.
The hospital fire brigade tried to water the facades, totally useless. They were spraying the walls with masses of water and reduced the temperature by only half a degree the whole time they were doing it. The rooms that were most comfortable were, in fact, the hospital car parks, which were underground, where there were a few droughts and where it was cooler.
In cities, buildings, roads, and infrastructure can be heated to 50 to 90 degrees hotter than the air, while natural surfaces remain closer to air temperatures. Concrete and tarmac soak up heat from the sun, warming the spaces around them and keeping temperatures high even after the sun has set.
The phenomenon of the urban heat island really emerged during the heat wave of 2003. The urban heat island is the fact that it is warmer in the urban area than in the surrounding rural area. This is often compared to a form of heat bubble that is found above the urban environment.
We have asphalt, and this absorbs a lot of electromagnetic heat from the sun's radiation, and it traps it within the urban environment. And so that makes the air around an urban environment hotter than it would be in a more natural system.
At night, the temperature stored in the concrete surfaces, which are often quite dark, will remain present in the city. The human body, in order to function properly, needs to be able to cool down during the night. This urban heat island can go up to 10 degrees in periods of summer, of heat wave.
Heat islands have become increasingly significant, as close to 70% of the world's population is expected to live in cities by 2050, exposing their inhabitants to extreme temperatures.
If you live in any number of large cities around the world, you have both the large-scale warming effect of global warming, but on top of that, you have this urban heat island effect. And that means that urban localities, and often, our urban regions are where we have the largest population of poor people, people who don't have the sort of access to air conditioning. They don't have the resilience that other people do. And so There is sort of an issue of climate justice here. Those who contributed least to the problem are likely to bear the worst impacts of climate change.
Climate justice is the recognition that some people are going to be more vulnerable to the impacts of climate change than others. Climate change is as much a social problem right now as it is an environmental problem. And we can address both racism and climate at the same time and hopefully uplift all individuals.
We need to be thinking also about ways of mitigating those impacts in urban regions. And there are things that we can do, green spaces.
The shade cast by trees helps to alleviate some of the absorption of heat by roads and paved areas. In addition, the trees release tiny amounts of water vapor from their leaves, which helps cool the air around them.
One potential solution for addressing some of these problems in our urban areas is something called green infrastructure, and that's when we purposely build green or vegetated elements within the built environment. And so it can cool the urban heat effect to a certain degree. It can provide more building efficiency, heating and cooling if you do it as green roofs. There are innovative ways of doing it, and thinking holistically about how you work with urban planners, how you work with ecologists, how you work with hydrologists, and community leaders.
We should have trees along the facades of houses, which protect from the cold in winter, and which protect from the heat in summer. Architecture is evolving. The next stage will be to change the roofs of Paris, the zinc roofs. We'll have to change them one day or another. And change all these ideas about air conditioning, which is a mistake, and in my opinion, fatal for the planet, right? Because now we've come to consume more energy in the summer than in the winter in some regions. And make sure that people can protect themselves in housing that's cooled naturally. That can mean thick walls, small windows, small doors. It can mean a lot of things.
Many European cities are already taking steps against the effects of urban heat islands.
Barcelona today has 1.5 million trees and is continuing to plant new ones. Milan also has another program to plant 2 million trees by 2030. So this type of program can be found in many European cities.
Meanwhile, in the French countryside, the heat wave takes its toll on agriculture. The worsening drought conditions are devastating. The increased temperatures cause crops to dry out through evaporation. Farmers complain of drastic losses of livestock.
When the weather forecast predicts a heat wave, we as farmers, and I personally, have our backs to the wall. You never know how long it will last. We have huge yield losses. So I had friends who had chickens on the farm. There were more than 50% losses and deaths.
Countries across Europe face their worst harvests since the end of the Second World War. In Central and Eastern Europe, some governments have to import food for the first time in decades. The consequences of drought caused by the heat wave are felt throughout the environment.
Drought in our forested ecosystems due to the warming of the atmosphere, and that's because there's more evaporative demand, more water being basically sucked out of our vegetated systems. So these trees are becoming more stressed. They don't have as much water to keep them wet and moist, and so they're more combustible.
Extreme heat can create a natural disaster that threatens the lives of people all over the world, like wildfires.
Fires in the western part of the United States, for example, 8.4 million acres have burned. That's 2 million acres more than the 10-year average that we've seen in the landscape. We have 8 more fires that are 100,000 acres or more. What's 100,000 acres? That's about the city of Phoenix. As a scientist, I've been thinking about climate change. I've been thinking about how these forests are changing. We're losing words to describe it other than apocalyptic or horrific, because it's happening at a pace that we just never anticipated.
Higher temperatures, largely as a result of climate change, have dried vegetation that fuel wildfire. Meanwhile, the drying up of groundwater is accelerating combustion.
Take that combination of heat and drought, and you have the conditions necessary for the sorts of unprecedented bushfires in Australia, wildfires here in the western US that we've seen in recent summers. And so we can say with some degree of confidence that we would not be seeing these massive, faster spreading, hotter burning, more extensive wildfires around the planet were it not for the human impact on our climate, the warming and the drying caused by the increase in greenhouse gas concentrations from fossil fuel burning.
The danger of wildfires to the planet is not only due to burning forests. An increase in global temperatures is causing fire destruction in the most unlikely places with serious implications.
We can see where the increase in heat will create more forest fires, thanks to numerical modeling, and their impacts, whether it is in the northern boreal forests, meeting northern Canada, or Siberia. We saw huge fires in Siberia, and that was actually predicted.
We're seeing it in Arctic ecosystems, so we're seeing fires in tundra and tundra systems underlain by permafrost, and that is carbon that has been stored for millennia. This is old carbon, and the Arctic is like a refrigerator. It's been storing that carbon for us. And now we're getting fires into those systems. These are slow-moving fires. They smolder, they release a lot of carbon, and they move slowly across the landscape, and they move deeply into that old carbon, releasing a lot of carbon into the atmosphere. That was being our protection. It was being naturally sequestered, and now it's going into the atmosphere, causing more warming, which is causing more fires.
After a full week of the heat wave in France, the human toll begins to emerge. Reports touch on a range of potential vulnerabilities: short-staffed hospitals, an aging population, a government on vacation, shelters and parks closed. Health officials are clearly recognizing the threat, but no one seems to know when it would all end.
The end of the event was a little harder to forecast, so when it had been going on for more than 10 days, and we still saw that according to the scenarios it could still last several days longer, it was true that it was something that was hard to imagine, since the duration of the event was quite awful.
For more than a week, the temperature in France remains around 99 degrees Fahrenheit or 37 degrees Celsius. French officials know they are in the middle of the longest sequence of consecutive hot days in France's meteorological history. While attempting to dismiss its impact, some French officials instruct first responders on the front lines of the crisis not to issue any alarming messages or give out the number of deaths linked to the heat wave to the press. Authorities are unwilling to hold normal life or August vacations from proceeding unabated.
On the evening of the 12th of August, there were more deaths in Paris than there were ever during the Second World War. The mortuaries were full.
After nearly 2 weeks of extreme heat, Europeans finally get relief as the anticyclone moves and positions itself over the British Isles. Slightly cooler air reaches France from Iceland, and temperatures drop by 4 degrees. It would not be until early September that temperatures would drop another 12 degrees, signaling the end to this historic heat wave in France.
The 2003 heat wave finally broke after August 15th. As the air mass became a little more unstable and a number of thunderstorms began to develop.
The period of extreme heat is thought to be the warmest in 500 years. Temperatures regularly reach above 40 degrees Celsius across the continent over a period of 30 days. The heat wave's death toll is unprecedented. Heat stroke and dehydration claim the lives of mostly elderly people.
2003 was a huge shock. Afterwards, they had to count the dead, so they came up with a figure to say, roughly, the heat wave caused 15,000 deaths. In fact, years later, there were researchers who looked at all the statistics And the heat wave caused a total of 20,000 deaths in France. It didn't only affect France, it affected the whole of Europe, and it caused between more than 80,000 deaths, probably 100,000. In 2003, we realized that we were there. We'd passed the tipping point. The atmosphere was different. We were in the climate change era. The heat wave of 2003 would also be the first time that researchers highlighted the link between climate change and a particular event. It marked the beginning of what we would call attribution, and we would go on to explain that the 2003 event was made more intense by climate change.
Heat waves are increasing in France, Europe, and everywhere in the world. It's a trend that appears to be getting more normal as the planet grows warmer and the climate changes.
We're talking about the release of fossil fuels primarily into the atmosphere, and then it becomes just chemistry in the atmosphere in which that carbon dioxide is basically re-radiating heat back into our environment, causing it to warm.
After the 2003 heat wave, climate researchers studied the link between climate change and the 2003 heat wave event. What they found was that global warming, the fact that the atmosphere was richer in CO2 due to human activity, had caused temperatures to rise by 1 to 2 degrees in this event, compared to what they would have been in the pre-industrial era. So in a way, the extreme temperatures observed in 2003 were already the consequences of human activities and climate change.
I think it can be said that the heat wave of 2003 was a brutal wake-up call to climate change. We talk a lot about climate change as something that is going to happen in 2100, so it seems very far away. It also seems very far away because we talk a lot about it on a global scale.
In sort of a worst-case scenario where we fail to reduce carbon emissions and we raise carbon dioxide concentrations to more than 3 times the pre-industrial level by the end of this century, then basically a third of the planet becomes unlivably hot. Heat indices that exceed 130 degrees Fahrenheit. Basically the entire tropics become unlivable. You can understand the immense conflict that will arise and the sort of potential societal instability that will arise. We're already seeing some of that in the form of environmental refugeeism, climate refugeeism. And that's why climate change literally does pose a threat to human civilization. Reached a point now where we're actually seeing the impacts of climate change play out in real time in the form of unprecedented extreme weather events.
C'est pas la première catastrophe.
This was not the first disaster in France, but was the first disaster due to global warming with social, political, health, environmental, and organizational consequences, and was still paying for the consequences, in fact.
Sanitaire, environnemental, organisationnel, et on est encore en train d'en payer les conséquences. Et il va y en avoir de plus en plus.
There are going to be more and more of them with consequences due to global warming, changes in vegetation, changes in food, the problem of access to water. It is said that the next wars will be fought over the availability of water.
Today, variations in the Earth's climate have exceeded predictions made decades ago using climate models. With the collapse of ice sheets in Greenland and Antarctica, the North and South poles are warming faster than the tropics. As a result, the jet stream, the meandering air current primarily responsible for heat waves, is changing.
So here in the Northern Hemisphere in the summer, we have seen these very unusual weather systems that just linger. They stay in the same place for days at end. A slower jet stream, a more wiggly jet stream that gives us larger weather anomalies. So we get these very deep, high-pressure systems leading to these more persistent weather patterns here in the middle latitudes, including these heat waves that we've seen in recent summers.
Some scientists now predict that in less than 20 years, millions of people in the US could be exposed to dangerous heat conditions of up to 127 degrees Fahrenheit. But heat waves will be most severe in the already hot tropics, in countries from Bangladesh to Sudan, where people may struggle to afford adequate cooling. Large parts of the world, from the Middle East to Siberia and Australia, have seen fast worsening heat waves in recent years.
A study by the World Health Organization says they calculate an increased impact per year of 250,000 people. So, 250,000 people per year exposed to the risk of heat waves. If we make the hypothesis that it continues at this rate, which is probably a little uncertain, we can assume that in 30 or 40 years, we'll arrive at figures of around 2 or 3 billion more people exposed. However, the climatic future of France, Europe, or the planet after 2050 is not set in stone. So the efforts we are making now can enable us to avoid having these mega heat waves that climate projections are forecasting.
I think that we can see climate change as an opportunity, because in fact it is a change that is here anyway, and which demands that we ask ourselves questions about the way our society is organized, both locally, regionally, and internationally. We have to find ways of adapting that suit us in relation to our values, and use climate change as a crucible to rethink our values.
An effort to limit the number of heat waves and their effects is one of the goals of the Paris Agreement signed by 197 countries in 2015.
The Paris Climate Accord was a critical development. It really committed all of the nations of the world to meaningful reductions in carbon emissions. It won't solve the problem on its own. It gets us maybe about halfway there. Under a Biden administration, we will see the United States re-engage with our global partners. And that means reducing our own carbon emissions, putting in place policies to incentivize renewable energy, to put a price on carbon to reduce carbon emissions. Then there is a path forward where we keep warming below that dangerous 1.5 degrees Celsius, 3 degree Fahrenheit warming level. So that's the good news. We still have time.
It is imperative today to follow the Paris Agreement. We cannot think about adaptation without also thinking about this other lever that is mitigation.
Our findings indicate that we do need to change our way of doing things. We need to get away from the burning of fossil fuels. There was now a detectable impact of climate change, and subsequently we've seen the damaging impacts of climate change, and we've been communicating this to the public and policymakers only to be attacked by vested interests and politicians working for them who find the science inconvenient. We've seen the same thing play out on a much more rapid timescale when it comes to the science of coronavirus, of COVID-19. We've seen how deadly that is. That toll has taken hundreds of thousands of human lives here in the United States. And so we have seen in real time how deadly that sort of anti-science can be. Here with climate change, we're dealing with an even greater crisis. We will get past coronavirus. We will get past the pandemic. But still looming in the background will be the existential threat of climate change.
Since 2003, weather models have, of course, made great progress. They have made enormous progress in terms of spatial resolution. And so today, compared to 2003, we're able to predict temperatures more accurately and perhaps better in terms of the exact location of the temperatures. We can also better anticipate phenomena several days in advance.
Extreme heat is already transforming our world. Disney executives recently voiced concern that rising temperatures will significantly reduce the number of visits to their parks. In Germany, officials were forced to put a speed limit on the Autobahn because of fears the road would buckle from heat. Researchers suggest that rising temperatures and humidity may make much of South Asia, including parts of India and Pakistan, too hot for human existence by the end of the century.
We have smart people working on the technology side. I think people just need to be incentivized. And I think once the politics falls in line there, I think we can move towards a brighter future.
I'm going to try to adapt my crops. In fact, it is genetic research that is changing with the wheat varieties. Some are more resistant to heat, others more resistant to humidity. So we really have varieties that manage to withstand, all the same, notably slightly longer dry periods than a few years ago.
vu qu'il y en a de plus en plus, on peut se dire que
Since there are more and more heat waves, we can say that our genetic defense against hypothermia is gradually being built up, and we are beginning to get a little more used to it. But if we reach extreme heat levels, you can imagine 55 degrees in Paris, there will be consequences. There will be dramatic consequences.
To protect lives in the face of the increasing threat of heat waves, there needs to be long-term planning.
Urban planning must take many, many things into account, speaking only of climate. For example, the size of the city, and therefore transport to work, to access services, etc., have a huge impact on health and on climate too. The type of energy that has to be used for a spread-out city or for a city that is extended more vertically is totally different for heating, for food. And so all these things have to be taken into account, and climate is the new order.
The Austrian capital Vienna has created a network of car-free Coolstraßen, or cool streets, that ban cars in certain neighborhoods and offer outdoor seating areas and cooling mist sprays which can lower ambient temperatures by several degrees.
The city of Paris has brought out an application called Extrema, aimed to provide information notably on what a heat wave is, the impact that it can have in terms of health, and how to protect yourself in your home, in your daily activity. But this application also allowed you to locate cool places within Paris. There are different topologies of cool places that were proposed, so it was the air-conditioned places. For example, swimming pools, parks and gardens. These different places were listed where you could go to be in a cooler place. There are a number of works that have allowed us to experiment with cooling furniture. We found some in Paris, but there are also experiments with cooling materials that use the evaporation power of water in the same way. We have seen examples in Nice with evaporative paving stones that were tested to see just how much the temperature dropped and whether this also had an impact on users.
In Nice, France, water plays a key part in keeping people cool. There are many fountains, lakes and rivers, not to mention the sea. But now they are also using pavement wetting systems, operating as a spray system, but also as a series of porous paving slabs that soak up water from their underside. They are designed to literally take the heat out of the city.
The evaporative cladding that was tested in Nice. Typically, there is a system of water networks under the paving stones that, according to the climatic conditions, will or will not start working, and thus will, by capillarity, make the water go up in the paving stones, so we don't have a puddle, finally, on the surface. It is really by capillarity that it works, and in fact, with the temperature, the heat outside, it produces evaporation, and thus it participates in the decrease of the temperature.